Hi everyone, we're going to look at 3.11 secant, cosecant, and cotangent function notes. The front side of this note packet is an exploration, so you can go ahead and work through that on your own. I'm actually going to jump right into the notes on the next page. So we are looking at our reciprocal functions, secant, cosecant, and cotangent. Secant, excuse me, by definition is the reciprocal of cosine. So that means we have 1 over cosine of x, where cosine of x cannot be equal to 0 because we can't have 0 in our denominator. Cosecant is the reciprocal of sine, so we have 1 over sine of x, where sine of x cannot be equal to 0. For cotangent, we actually have two ways that we can write this. We can write it as 1 over tangent of x, where tangent of x cannot be equal to 0. Or, since tangent by definition is sine over cosine, the reciprocal of that could be cosine of x over sine of x, where sine of x cannot be equal to 0. Since all of these have something in a denominator, that means that the graphs of each of these reciprocal functions will include vertical asymptotes. Whenever the denominator is 0. That means our graph cannot go there. It's part of one of our undefined values. So we're going to look at the domain and range for each of these. I guess I should leave that up there. So for secant, if you notice, this dotted line in here is the graph of cosine. So we can see the relationship between secant and cosine because at a maximum of our cosine graph, that's part of the minimum of the top portion. And then down here at a minimum, we have a maximum of the top portion. So we can kind of figure out what the graph would look like. If we know what cosine looks like, we can fill in the spaces for secant. So for our domain, because we have vertical asymptotes, it is x cannot be equal to pi over 2 plus pi k, where k is an integer. If you notice, it's kind of hard to tell, but we have pi over 2. This would be 3 pi over 2, 5 pi over 2, 7 pi over 2. So we have pi over 2 plus pi, which would give us the next asymptote, so on and so forth. For our range, since our graph is made up of like two portions, we have the top u's and we have the bottom u's. So if we start with the bottom u's, our graph goes down to negative infinity, and it goes up to this point right here, which is at negative 1, and we want to include that negative 1 value because our graph touches it. So it could be in those bottom pieces, or, that's a symbol for or, it could be in a top piece. We are at positive 1 and we go up to positive infinity. So again, we want to bracket with that positive 1 because that number is included, and then it goes up to infinity, and we can't have the end of infinity included because there is no end, so we use a parenthesis. Moving on to cosecant, we can see similar things. So we have our U shapes on the top, we have our U shapes on the bottom, except they're shifted over slightly because sine goes through our origin. We can see that here, if our sine has a maximum at 1, that is minimum for that top portion of our U. And so very similar to cosine and the relationship with secant. So we have sine sketched in here, but the actual graph of cosecant are the u's and then these u's at the top. So our domain is x cannot be equal to pi times k, where k is an integer. And we can see that here at pi, 2 pi, 3 pi, 4 pi, negative pi, negative 2 pi, negative 3 pi. Our range is actually going to be the exact same as it was for secant. So we have negative infinity to negative 1, where that negative 1 is included, or it could be part of that top section, 1 to infinity. For cotangent, we can see it's actually similar to tangent. If we remember our tangent graph, it actually increased as we went from left to right. So the lines went the opposite way. These are actually decreasing from left until right. Our domain for this is x cannot be equal to pi k, where k is an integer, because we have asymptotes at 1 pi, 0 pi, negative 1 pi. It would be at negative 2 pi, negative 3 pi, so on and so forth. And then our range for cotangent, it is going down forever and it's going to go up forever. There would be arrows on the ends of these, so our range would be negative infinity to infinity. So we're going to look at a couple examples together. So I'm going to scoot this up a little bit. So looking at example 1, it says let f of x equal 3 times secant of 2x, which of the following is a vertical asymptote for the graph of f. So there's two ways to do this. If you have the domain memorized for secant, you can think of this 2 as a period change where it's getting compressed by a factor of half. Or we can remember that secant by definition is 1 over cosine. So what that means is I could take this portion here, secant of 2x, and rewrite that in terms of cosine, which is 1 over cosine of 2x. The 3 is my amplitude for secant, which actually isn't going to affect where my vertical asymptotes are, so that is why I chose to leave that 3 out. The part that's going to tell me about my vertical asymptotes is the part that's in my denominator, and because I can rewrite it like this, I can see what's in my denominator. Well, now I know that whatever's in my denominator cannot be equal to 0, so I'm going to set it equal to 0 to figure out where those values are at. So I know that I have some vertical asymptotes at cosine of 2x equals 0, and I can go ahead and solve this. I take arc cosine of both sides, so that would leave me with 2x equals arc cosine of 0. Well, arc cosine of 0 means at which angle is a cosine value 0, and I know that happens at pi over 2. If I was including my whole unit circle, it also happens at 3 pi over 2. I'm going to see if this works first, and then I might have to use the other value if I don't see my option here. So to solve this, I want to divide both sides by 2 to get x by itself. If I'm dividing by 2, that is the same thing as multiplying by half. So I would have x equals pi over 2 times 1/2, which would give me pi over 4. So I know that I have a vertical asymptote at pi over 4 and every equally spaced place after that, so my answer would be C. For number 2, it also asks about the vertical asymptotes, and we can actually do it the same way. So my amplitude of 2 isn't going to affect my vertical asymptotes, neither will the reflection. Technically, this 4 could be written on the end as a +4, which is a vertical shift up 4, which will not affect where my vertical asymptotes are. So again, I'm only looking at cosecant of whatever's inside my parentheses. I can rewrite this as 1 over sine of pi x, because cosecant can be written as 1 over sine. So that means I know that I have a vertical asymptote whenever sine of pi times x is equal to 0. So I'm going to take arc sine of both sides. So I get pi times x equals, I have arc sine of 0. So arc sine of 0 would give me 0 or pi. So I'm actually going to write both of them down this time. And then when I divide by pi to solve for x, well, 0 divided by pi is 0. And I don't see that as an option. So I'm going to do this one. I'm going to solve for x, divide both sides by pi. Pi divided by pi is 1. And so that would mean x equals 1. So I know that D is my answer for example 2. Looking at example 3, it says let h of theta equals 3 times cosecant of theta over 2, which of the following gives the range of h? So I know that for cosecant, that is based on my graph of sine. So off to the, I'm going to go down underneath here. Sine starts at my origin, and it looks like this, which means cosecant has these U shapes that are based on where my max and mins are. So this would be my cosecant graph. So those black U's. Now what I'm looking for is the range of cosecant. So I'm trying to figure out my Y values. Well, a 3 means that the amplitude on my sine curve is 3. So my maximum would occur at 3. My minimum would occur at -3. There's not a vertical shift up or down. And so that helps me figure out my range for cosecant. If this maximum of sine is at 3, that means the minimum here is at 3 and it goes to infinity. And so automatically I can narrow down all of them to C, because if I'm going from -infinity to -1, that means my amplitude is just 1. Here, my amplitude would just be 2. This has an amplitude of 3. And then this one, it can't be, because this would be my range for my sine curve, what's in between -3 and 3. But since I'm looking at the black portions, I'm looking at this side or this. So I need 2 separate sections that are not intersecting.